Gwanghyeok Ju for coming all the way. He came from about the same distance as James did, only from the exact opposite part of the world. We're very privileged to have him here to talk about the Korean Lunar program and potential science opportunities. So, Gwang.
Yeah. Nice meeting you. Actually, this time I have a double burden to make a presentation just before the lunchtime. Even for me, it's speaking in the midnight, actually. So I couldn't overcome the jet lag. So sometimes if I say it in Korean, you may prepare the Google Translator. Okay. Okay. So I'm going to give you a brief the introduction and update status of the Korean Lunar program. So actually, the Korean Lunar program is composed of two different phases. The first phase is kind of a Korean Lunar Pathfinder orbiter, and the second one is maybe orbiter and plus or just lunar lander only. So we're gonna first of all we applied for both to our government, but the only first phase was approved, and then after maybe later this year, so we are going to reapply for the official approval for the second phase. So our Pathfinder orbiter is mainly for the technology demonstration and science. For the first time, it's only for the technology demonstration, but the science community is we need also the kind of a demonstration for the science trial. So we plan this started the 15 to 18, but so actually we started this year because the budget cut budget. Even though 2 years ago we approved, but the budget has started as this year. So so the launch year will be slipped to 2019 or early 20. So it's under discussion with the final official approval with the government. So the main feature of the so mission objective is lunar exploration technology development and investigate lunar resource and magnetic environment. And so we are looking for the proper landing site. And so realize the new space-based technology by demonstrating a space internet, something like that. So our planned activities already this week. So we are having the SRR. So we already have had a mission definition review. And then, so we are under discussion as maybe NASA headquarters is under preparation for the make announcement for the AO, NASA Science Payload, for KPLO. And we are going to have an official MOU sign up in the fall. And also we get started again officially with the government lunar lander strategic planning study. Even though we did this kind of study so 2 years ago, but in order to get the official approval, so we have to do again. So this is a slightly changed KPLO configuration. So previously we just benchmarked just like LADI shape, but so the mechanical design engineer has been changed. So he changed very simple configuration like this. So also we will have one solar panel. We already assigned almost the scientific payload location and except a NASA science payload. So this is mission trajectory. So actually that will be launched, foreign launch vehicle, even US launch vehicle or Indian launch vehicle. So maybe we are going to face plane orbit and then the lunar insertion orbit up to the 100 kilo altitude, but we can down to the 50 kilo if possible. So the key program status is currently we already the kickoff and science payload selection in April. Three scientific instrument was selected, plus one optical payload from CARI. And I mentioned so NASA headquarters is preparing the release of the scientific payload AO very soon. I heard. So this one is a brief overview of the schedule up to now till the select the KPLO science instrument. So actually last year we did some kind of a survey, so a domestic lunar science demand. So 19 proposal was collected, and then we after releasing the AO, so 9 proposal submitted domestically, and then 3 instruments selected by considering the mass budget and our so national budget. So here is the 3 selected Gamma Ray Spectrometer and polarimetric camera and magnetometer, and plus with a high resolution camera with a stereo camera that I show you later. And then we are going to the prototype of space internet to make a test with some DTM protocol and with the NASA under the NASA provided space internet standard. So we will going to use this space internet platform again to our rover and lander or other some device installed on the lunar surface. So here is some payload development network. Actually, basically, we recommend every scientist have a cross relationship or collaboration partnership with a foreign agency or university. So GRS, Gamma Ray Spectrometer or other magnetometer has a close relationship between them and other country. So also we recommend, we request to the NASA headquarters. So if NASA instrument is selected, and then Korean scientists can join the the instrument development or the taking some make a contribution for the science itself. So even though we did some kind of scientific definition study, but it was not officially approved. So without exact clear science definition for KPLO, we just release AO and then collect some idea. And then after selection, we kind of some defined specific mission objective for KLO into the three different categories, and lunar mapping and finding lunar resource and geology and lunar environment. So this is a picture for the conceptual drawing for our lunar terrain imager, led by Kari. So field of view is so TBD, so maybe up to the 20 to 30 degree, and ground sample distance is less than 5 meter. So even though so far the robotic mission, LRO is most accurate resolution, but even though under the 1 meter resolution, but the whole coverage is not completed yet. So we are going to make a focus on the uncovered by the other robotic mission. So we make a more detailed lunar mapping, lunar terrain mapping with a less than 5 meter GSD. So this is a brief drawing for the gamma ray spectrometer. This is going to use in the firstly, so LA bromide scintillator detector. So by using this detector, so they're gonna have a new approach to collect low energy gamma ray signals, even by either X-ray fluorescence or by natural radioactive decay in the low level, as well as high energy region up to 10 mega eV. So scientific objective is lunar resource, including the water and volatile measurement in the especially polar region. And then so some focused on the magnesium or other some specific element, the distribution and or lunar impact history evolution will be developed. Also, the KGRS team want to investigate the lunar environment by mapping the global radiation from KV to the 10 mega eV range. So actually, the previously Chang'e or Chandrayaan, other lunar robotic mission, most of them they have a loaded gamma ray spectrometer, but their detector range is something like this. So most of them are so less energy coverage was not covered. So our gamma ray spectrometer is the most wide range of from this area to up to 10 mega eV. That's why they have chosen the kind of new scintillator. So actually, this is a shape of the preliminary shape of the wide-angle polarimeter. We call it POLCAM. So its swath width is 35 kilo, and then this has a two mode, some according to the some polarimetric angle. So we also are thinking this polarimetric camera into merging into our lunar terrain imager. So they're gonna find some the map or distribution for the grain size or the roughness of regolith. Otherwise, and then titanium, the contents, especially high resolution titanium map so far. So they hope to build up the highest resolution of the map ever, the TI map. And magnetometer, their main focus on the characterize the distribution of magnetic anomaly and its related science, cooperation with the UC Santa Cruz and NASA Ames. So originally we wanted to jettison to the CubeSat impactor, but still it's not fixed. Actually, even when we release AO, so CubeSat impactor as a scientific payload is a kind of some optional, so they have to compete with other scientific payloads. So previously, the CubeSat was as a default, but so we eliminate. So anyhow, this magnetometer want to characterize this kind of mainly magnetic anomaly on the moon. This one is a shape. It's almost the total the 0.2 kilo, and then so boom is around the 2 kilo, and then boom will be the installed at the outside is main spacecraft body. So besides main scientific payload and its related science, we are preparing the very variety of the research topic related to KPLO or for future mission to lunar lander. So we are with the other source of funding, we are going to the lunar image generation tool development, and then landing site selection study already started, and then lunar landing GNC and rover technology and kind of some end-to-end simulation platform has been also started for KPLO and lander program. So the international collaboration AO plan is briefly summarized. The continuous data rate and then power is maybe depends upon the progress of our subsystem, but the strictly the total mass of the NASA payload is between below the 15 kilo. So this is a brief drawing for the end-to-end performance simulator. So we are going to have GRS and imager and separately or together. So once we have launched or before launch, in order to get the idea from each channel, or we can simulate from end-to-end performance simulator by visualizing the visualizing the final image final output from GRS after a virtual calibration process. Then we will visualize that kind of thing on the Vision Bench before launch and after launch, and we're gonna use kind of some as a backup of a ground station. So summary, 3 scientific instruments and plus 1 imager was selected for KPLO to discover the new feature of the moon. And then AO for the NASA science payload will be released very soon. We would like welcome, so through the especially survey, we hope to keep the concrete collaboration relationship through this place. And then NASA, after that, maybe CARI NASA MOU will be signed up by the end of this year. And hope to join us and then hope to work with you. I'm looking forward, waiting, promising partnership with the U.S. scientists through the survey. Thank you.
Thank you so much, Gwang. We're very proud of our partnership, and it's just got to be an amazing moment in your country's history, starting this program. So we might be able to take one question, but I don't see anyone rushing to the microphone. So if we could thank Gwang again. Thank you so much. And let's reconvene at 1:45, please. Thank you.